Hello, and welcome to the Data Engineering Podcast, the show about modern data management. If you lead a data team, you know this pain. Every department needs dashboards, reports, custom views, and they all come to you. So you're either the bottleneck slowing everyone down, or you're spending all your time building one-off tools instead of doing actual data work. Retool gives you a way to break that cycle. Their platform lets people build custom apps on your company data while keeping it all secure. Type a prompt like, build me a self-service reporting tool that lets teams query customer metrics from Databricks, and they get a production-ready app with the permissions and governance built in. They can self-serve, and you get your time back. It's data democratization without the chaos. Check out Retool at dataengineeringpodcast.com/retool today, that's RETOOL, and see how other data teams are scaling self-service. Because let's be honest, we all need to retool how we handle data requests. Composable data infrastructure is great, until you spend all of your time gluing it back together. Bruin is an open-source framework driven from the command line that makes integration a breeze. Write Python and SQL to handle the business logic, and let Bruin handle the heavy lifting of data movement, lineage tracking, data quality monitoring, and governance enforcement. Bruin allows you to build end-to-end data workflows using AI, has connectors for hundreds of platforms, and helps data teams deliver faster. Teams that use Bruin need less engineering effort to process data and benefit from a fully integrated data platform. Go to dataengineeringpodcast.com/Bruin today to get started. And for dbt Cloud customers, they'll give you a $1,000 credit to migrate to Bruin Cloud. Your host is Tobias Macy, and today I'm interviewing Kostas Pardalis about Fenic, an opinionated PySpark-inspired dataframe framework for building AI and agentic applications. So Kostas, can you start by introducing yourself?
Of course, and thank you so much for having me here and talk about myself and Fenic. So, about me, I've been building data infrastructure for the past 11 years now, starting with Blendo was my first company. I was also founder there, a cloud DLT solution. Started around the same time with Fivetran and Stitch Data. Then through an acquisition, joined Rudderstack, joined like the leadership team there. Rudderstack, for anyone who doesn't know, again, in the ingestion layer, but focusing more on capturing like events like data and ingesting this data into data infrastructure like data warehouses and data lakes. And then after that, I worked together with the creators of Trino at Starburst Data. Learned a lot about query engines, and I worked on expanding Trino and the products that Starburst had into the batch workload. For people who might not be aware of, like, Trino traditionally has been used primarily for online analytics. There was some incredible engineering work that added fault tolerance to the engine at some point. And that allowed the system like to expand into like the batch workloads that Spark traditionally was, let's say, like dominating. And the past like a year and a half working on a new project. I'm founder of a company called TypeDev, where we build what we call agentic data infrastructure. So it's data infrastructure primarily focusing on like data engineering use cases. And we're trying like to tackle like the problems there using agents as part of the mix of the infrastructure. Part of that work also allowed us like to open source like a project called Fenic, which we'll talk more about. But yeah, that's about me.
And do you remember how you first got started working in the data space and why it has kept your attention for this long?
That's a good question. Somehow I was always gravitating through that, even like during my, let's say, academic years. I remember there was a time where I was trying like to decide if I wanted to pursue more of like a PhD, or I wanted to get into like the industry as like an engineer. And that time I was working with some research labs, and somehow I ended up like again like working with knowledge representation, data modeling. Back then it was like a thing called like the semantic web, things that kind of like return today, like we start talking about graphs again and like RDF and like this kind of like technologies. Somehow like I started with that, and then the next step when I decided that okay, like academic world is not my thing, let's try the exact opposite, which is start building a company and building products, I ended up like building Blendo and getting into like the data pipelining world and like the ingestion. And I don't know, there's something about like data that makes things a little bit more complicated, but also has like a very direct mind, at least like connection with value, because data is like things that we can always associate with something that we try to do, right? That keeps fascinating me and like keeps me getting back there and working on that. So I guess that's the reason. I don't know. We'll see. There's more to learn about myself, I guess. Like keep asking this type of questions, like new things might come up that surprise me to myself too.
Absolutely. Yeah, well, I mean, that's the point of life, right? The journey of self-discovery.
100%. Through data.
Of course. Quantified self.
100%.
So you mentioned the Fenic project that you open sourced, and I'm wondering if you can just describe some of what it is and the story behind how it came to be and some of the core problems that you're trying to solve with it.
So when we started with TypeDev, what the problems we're trying to solve was about, okay, we have like the data infrastructure that we are using like today, which has been kind of defined pretty much like 12, 13 years ago, where the world was like very, very different, right? Like if we think about the OLAP, data warehousing, and moving all these things like on the cloud, the modern data stack as was like called, and like all that stuff, pretty much we are talking about taking some ideas that existed for a long time and making them accessible like to more people and making them like scale beyond, let's say, the scale that we had like before 2010, like Spark, Trino, like Snowflake, Redshift, all the BigQuery, like all these solutions that they are kind of like, let's say, the foundation of, let's say, the infrastructure we are using like today. They are primarily built with two strong assumptions. One, that the dominant use case is like analytics, so it's like BI. And the second one is that you have some people to run these systems that they have pretty good technical skills, right? Anyone who has been like, let's say, in part of like a platform team where they have to babysit EMR Spark, for example, they know exactly what I'm talking about, right? Now, this creates, let's say, it makes it hard like for the adoption of like this solution, like to become like more broader, like available. There were like some attempts. I think one interesting approach was DBD came out. It tried like to create also like this new type of engineer, like the analytical engineer, which is more of, okay, we can get someone who is not necessarily a person who's like expert in, I don't know, like distributed computing and consistency and what it means like to run like fault tolerant systems across like hundreds or like thousands of nodes and all that stuff, and like kind of like turn them into people who can scale the infrastructure that we need. But still, like the problem was there. Like we couldn't see like some escape velocity being like developed in the industry where more and more people could use like this technology. So that's where like the starting point, how we can make, let's say, data infrastructure more accessible like to more engineers out there, and like kind of abstract some of the really hard parts of like systems that they are not necessarily in place because of like data, but they are there because of like the distributed nature of like these systems. So in order to do that, we wanted like to start from scratch in a way, instead of like, let's say, taking Spark or Trino and trying to make it serverless or like abstracted. So we're like, okay, let's see what we can build if we start from the query engine itself, and how this query engine should look like, especially if we are focusing on the workloads that, let's say, data engineers and like data platform people are like working. And we started like thinking what that would look like, what the API should be, what we should people like to use as the interface, and what new elements we should put there, right? The world, again, it's not 2010 anymore. there are more out there. Like we have to work with new types of data, and most importantly, because of AI, with a new type of compute, which is inference, right? So the core of what we were building was like this new query engine that we wanted it to make it easier, like for people like to use it, being familiar for people who have been working with the pipelining side of things, and also make first-class citizens this new type of compute, which is inference, and also build it and design it in a way that will make it efficient now that the nature of the workloads like has changed. Like we're not talking about like CPU bound workloads anymore, which is like what we were optimizing so far with like columnar systems. Now we are more like, I would say like IO bound, because most of the time we have like to go and wait for like an LLM like to respond, and for GPU like to start like streaming tokens back. So let's say how Fenic came into life, like how we started like working on that. So it is like a query engine to make it accessible like to both humans and machines. We wanted to use an API that it's already familiar to people, so that's why we decided like to use PySpark. Dataframes, my opinion, are like important because they give like this really beautiful API of like mixing imperative with declarative and have like best of both worlds, because when you work like with data outside of like the purely analytical use cases, the purely declarative is not necessarily the best way like to do things. And we also made it like we added like inference as like first class citizen, as we say, by enriching and the existing API that like people know. So instead of like building UDFs where you call an LLM and you just think of it as like an API that you call and you send something, you get something back, but then the optimizer can't do much because it's just like a black box. What can we do to add, let's say, these relational operators inspired operators like in the API to make the composition and like the API more familiar to use like also inference together with classic like data processing, and also expose that to, most importantly, to the optimizer, because now the optimizer can go and reason about how to reorder operations and do it like in a very efficient way by knowing that, oh, right now like I'll need at some point to go and do inference. So maybe I should optimize the plan differently. Of course, we wouldn't come up with these ideas without getting inspiration from some really smart people out there who have tried like to do some of these things. There is like this like a great team like at Berkeley that came out like with the Lotus system and like the papers where they were posing in pandas these semantic operators, let's say, as part of like pandas. We kind of like took that, but we wanted like also to not focus only on that, but more on the engineering side of like, okay, how do we put this like into like in a more like production kind of like system, right? Like something that, okay, you don't only prove like the feasibility of like these operators, but also like put them into something that like people can actually use it regardless of like how much data they have. And that's how Fenic was kind of like designed. I'll pause here. So if you have any questions on that, and then I can get into like more like technical details, because it's not only that part. There's a lot of work that has been supported by using things like polars, for example, for like the processing, and some other things that like we can talk more.
Yeah, I'm definitely interested in digging into some of the guts of Fenic and the ecosystem integration. Before we go too far down that road, I think it's also worth exploring a little bit more of the utility of having the Dataframe API being the predominant design consideration for Fenic, where tabular data obviously is very predominant with data warehouses, with the number of data frame libraries and implementations that exist. But in particular, when we start to incorporate more unstructured data sources, you might have a higher dimensionality than just the XY axes that a data frame will likely constrain you to. And with the focus of Fenic being and incorporating some of these LLM and generative AI capabilities into that data engineering flow and generating some structure from that, I'm curious how you see some of the trade-offs of that tabular representation or that 2D constraint factoring into some of the design and usage considerations for Fenic.
Yeah, that's a great question. And I have like to add something here. There is a very I would say, like an important assumption that has influenced a lot, let's say, like the design and the goals at the end of Fenic. So this assumption is about how, let's say, LLMs can be used in a way that it's more predictable at the end, right? And we start like from, as you said, there is like a lot of unstructured information out there, but this unstructured information has a lot of information, like a lot of structure that is like implicit. Now, instead of saying, hey, I know that this information is there. Let's say I have like conversations with customer support, right? I know that this information is about, let's say, my product, and it is about like specific features, obviously, because like people reach out because they have problems or questions about specific features. And asking every time I have a question, the LLM like to come back and give me like the answer of what's, let's say, the feature of this. What we can do is we can make this information explicit and part of the schema. And that's where, let's say, the tabular nature of like data frames comes in, right? So instead of, again, like querying using LLMs like the raw data, what if we go and say, hey, I know what this data is about. I know that in order like to process this data, I need to understand, let's say, to extract some entities. Why not extract once these entities, add them as columns in there, right? And then either continue using that information using LLMs or standard like ways of doing processing, which you do want to do, right? Because when you try like to scale anything that you can substitute the LLM with, let's say, a deterministic way, not only adds like more reliability, but most importantly, like scales much better, like the more data that you have. So, and that's what like the operators, like these semantic operators are like about, right? Like when you use something like, let's say, like a semantic group by, which is kind of like the equivalent of like doing clustering, or using like a semantic extract that returns back like a structure that has a schema that you add there, like with data type and like a struct in place. The goal is to go from this implicit structure that exists in your unstructured data into a more structured, explicit schema that you can track, you can update, you can reason about. The model can also reason about, right? And you can process in a continuous manner, like as like data engineers have always been doing by building like pipelines. So that's like an important, like, let's say, assumption here. The goal should be using the LLMs to make sense and add structure and order in this data that we have, so we can reason more efficiently, both using LLMs and the relational algebra that we've been using like until like today. And that's what you should do like with Fenic if you use it. That's the goal, right? So we approach the problem and why we use like data frames and why this tabular representation at the end, I think it's really important. We shouldn't let it go away. We should make it more powerful and more expressive by having LLMs in there, instead of saying, oh, we don't need schemas, we don't need types, we don't need any of that stuff because we can just like throw the raw data like in an LLM and get like a response. No, it doesn't work like that.
And so now digging more into Fenic itself, can you give a bit of an overview about some of the implementation details and some of the core architecture of the project that you settled on to be able to take advantage of some of these data frame primitives while bringing in the LLM operators?
So one important, let's say, characteristic of the data frame concept, let's say, or like API, is laziness. It's something that you compose, and when you are ready, like you can go like and evaluate it. What that allows you to do is that it allows to go and apply, let's say, an optimizer to go and optimize the plan, like go from the data frames that you like, the AST that has been created like from your code, to a logical plan, the logical plan being optimized and then turn that into like a physical plan that then you go like and execute. Now, why this is like really helpful is from the user perspective. Obviously it helps with composability, right? Like, so users can go and write like really composable code, something that like SQL was like always like struggling with until, let's say, something like DBT came into and tried like to add that by using like templating. But most importantly, you can now use your optimizer like to reason and use it like as more like as a compiler, let's say, like to go and figure out like the optimal way of going and like executing things. And while things have been like solved for like the columnar data that we've been like processing so far, that's not true when you get into the equation also like inference, right? So the way that people have been doing it like so far is like building UDFs. So you pretty much consider inference as like an API call that's part of your code. The problem with that, and traditionally it has always been like a problem like with UDFs, like for all systems, including like Spark, is that a UDF is like pretty much a black box. So the optimizer itself cannot reason about what this thing is like trying like to do. So by taking like the LLM interactions, creating some specific operators that they are part of the logical plan, we achieve like two things. One is that now the optimizer understands that, oh, I'm going to process the data using LLMs, but also for like a specific task. So it's not just like a generic thing, again, that it's tokens in, tokens out, but it knows that, oh, this is a semantic predicate, which means that this is going to be about deciding true or false based on like some input, and this allows for like specific, let's say, optimizations that can be done. Or this is like an extraction task, which means that now I can use different type of optimizations, or a semantic join, as we like have another like operator. All these now, like the optimizer itself is like aware of like what we try to achieve using LLMs, and by considering also what inference is as a type of compute, it can incorporate that information to more optimally create and execute the plan. The reason this is important, especially like for like working like with LLMs, is because LLM calls are expensive. And when I say expensive, it's not only like in dollar amount. It's like expensive in terms of like time to work with these things, right? So the last thing that you want is something like to fail because you did, I don't know, maybe you went over the quota that you have, or maybe you sent more tokens than, let's say, they are allowed in the context window that you have, right? Now, all these things that like we as developers are aware of, the optimizer, when you are using just like a UDF, is not aware of, right? So we make all these informations like explicit and part of like the logical plan. So now you have like a system that when you, let's say, you take some data, you do some string matching or whatever at the beginning, or like splitting strings or blah, 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 whatever. And then you're like, okay, now I want like to go and extract, let's say, some information using LLMs. The Fenic will be able like to execute this thing like in the most optimal way, considering also, let's say, like the parameters of like the inference engine that you have, right? So it will make sure that it's like fault tolerant, like it won't, let's say, throttle your APIs, or like if something gets throttled for whatever reason, it will back off, and it will respect, let's say, like all the limitations that the LLMs have, with the end goal of that being obviously being like more efficient and more like fault tolerant when you are like incorporating these LLM operations in your data processing. From the user perspective, right, like the developer who's writing the code, it's now much easier like to maintain and reason about the code, because you're not just have like a chaos of UDFs that you also have to go and like figure out and reason about what they are trying like to do. You have specific operators that you can compose as you did with a regular join, or like a regular filter, right, or a group by. But now you apply these things also like with semantics, and you do it also in a way that you know end to end what the types are going to be, and these are like guaranteed by like the engine. So that's the, let's say, the high level approach that Fenic has. The way that we have implemented that, we built our own. So we have implemented, let's say, again, it's like a PySpark-inspired API. You write code that is very familiar to anyone who has like written like PySpark code, with some extensions, obviously, because we have like semantic operators there. That gets parsed, creates like a logical plan. This logical plan gets optimized, and then when we move into like the physical plan, this is actually executed by polars. So we translate that into polars, and polars executes that. And of course, anything that has to do with the LLMs is happening, like it's built like with Fenic. We also support SQL. What happens there is that we have, using obviously like the magic of Arrow there, like the operation with DuckDB. So like you can write SQL, which is DuckDB SQL, and it can be executed by DuckDB. But all these things are like transparent at the end, right? Like you see just like Fenic, you write like in Fenic, and Fenic does all the hard work of making sure that everything is like translated correctly between DuckDB when it has to polars and back into Fenic again.
And as you have been building and iterating on this project, what are some of the ways that the core principles and scope of the project have evolved from your first experiments with it?
There are some interesting things. One of the things that I found like very interesting. So at some point, we added support for MCP into Fenic. So now like you can pretty much write any code you want over your data, like using like data frames. And you can turn this into what we call like a tool. So Fenic has like a catalog, like an internal catalog. And we kind of had like, as you have like views and tables, right, as like the standard components of your catalog, we introduced like a new one, which is the tool. So now you can create in the catalog a tool which is associated with some code that you've written, like as you would, the same way that you would create, let's say, like a view, you create a tool, and that is like exposed by Fenic like through MCP. So you make this like available to any model to go and interact with it. And Fenic takes care of all like the plumbing and like all the boilerplate and everything that is needed there in terms like to both like build and serve the MCP. So for me, there is like a great opportunity there to create like tooling for the LLMs like to interact with data. If we think about like MCP, like traditionally it has like it's been around like connecting with services primarily, right? But we haven't like yet figured out what MCP would look like for data. And our attempt like to address that is by using, let's say, the data frames, introducing a new type of catalog object, which is like the tool. And as you create views, like as you would create parameterized views, like in database, you create parameterized tools in the catalog, and these tools then can be exposed like through MCP to any model.
You're a developer who wants to innovate. Instead, you're stuck fixing bottlenecks and fighting legacy code. MongoDB can help. It's a flexible, unified platform that's built for developers by developers. MongoDB is asset compliant, enterprise ready, with the capabilities you need to ship AI apps fast. That's why so many of the Fortune 500 trust MongoDB with their most critical workloads. Ready to think outside rows and columns? Start building at mongodb.com/build today. And so one of the key positionings that you're doing with Fenic is that it helps to bring reliability and rigor in terms of data engineering principles to LLM-powered transformations. Obviously, there are varying elements of probabilistic outputs, unpredictable results that you might get. Obviously, since you're dealing with various API calls, there's the potential for failures. What are some of the anti-patterns that teams that are starting to build with Fenic should be aware of, and some of the ways that they might inadvertently shoot themselves in the foot because of the way that they either design their transformation flows, or some of the ways that they structure the prompts, or even restrictions in terms of the size and scale of data that they should be thinking about operating on within a certain batch of requests?
Yeah, first of all, I have to say that in my opinion, like data engineers are like kind of the right people to bring like to solve these non-deterministic like problems that LLMs have. Like it's not that there's a lot of non-determinism like when you work with data anyway, right? Like it's not a new thing. That's what, let's say, kind of what data engineers have been always like fighting with, like how we can create like more determinism like out of like the systems that we have. And why do I say that? First of all, like even like with traditional ML, right? Like there are processing steps that they are by nature non-deterministic. Running pipelines that they are incremental, they are not necessarily like deterministic. Things can fail at any point, right? And at any time. So that's also like part of adding like non-determinism in the system, like over. Like at the end of the day, data engineers are trying like to fight against entropy in a way, right? That's like their job. So if there are some people out there that they can deal with these things, I think it's like data engineers. The principles that they used in like before LLMs, like actually apply them. like on working with LLMs too. What I would say in general, I think some like best practices or like guidelines. The most important thing, in my opinion, is to think like in an incremental manner, like when you work with LLMs and like data, and instead of going, because like people tend to go directly into, oh, like the LLM is going like to give me the answer. Instead of doing that, think in terms of like pipeline, right? Like I have this data that in its raw form is like that. How can I get in the what's like the minimum number of steps to extract information and structure my information in a way that like downstream we have guarantees about what we are doing here. So in the same way that, let's say, we start by getting the raw data and doing some cleaning, right, to get our data like in shape, that's where like I think like LLMs like should start being like employed, right? How we can take now the unstructured data that we have and start like creating some structure. And from this structure, how we can apply, let's say, the tools that we have to reason about the quality of this data and decide, should we push this further downstream or not? This is like the way that I would approach it, and like I would suggest anyone like to do it, like just follow like engineering principles that have been working like all these years, but apply them using like a new type of compute, right? It's not going to be exactly the same thing, obviously. Like there are like some other like parameters that you have to take into account. But at the end of the day, like if you architect the system, if you think like in a more abstract way, you should be applying like the same principle. The other thing, like when it comes like to let's say using LLMs, is that because of and that's more of a systems thing actually, and I don't necessarily think that the data engineers should care about that stuff, but adding async capabilities in the query engines is becoming more and more important, right? Which is something that we had also like to implement like at Fenic, like we added like async UDFs. You need that. And you need that because there are many steps that you have like to take and process, where if you don't asynchronously like make the calls as part of like your plan, you are going to underutilize your resources like heavily. But again, that's not, this is more for like the systems engineers that they build the tooling than it is like for the data engineers themselves. But async becomes like a much more important, let's say, technique that needs to be incorporated into like the tooling that we have and use it.
For people who are adopting Fenic and they're starting to take advantage of some of these semantic operators that are built into the data frame, what are some of the common tool chains that they might be coming from? And what are some of the common first steps that they're going to take as they start to adopt some of these more semantic operators beyond just the traditional transformations of maybe doing projections or converting from one type to another within a particular column, etc.?
Yeah, I think Fenic is like anyone who has used like Pandas or has used like PySpark or any data frame, let's say like API before, like Fenic should feel like very familiar. The semantic operators, there's like a small set of them. What we tried like to do there is to create, let's say, a semantic equivalent of like standard operators, right? So what it means like to filter something like semantically, right? Or which is like a semantic filter that you can do like with Fenic. Or you extract information, it's more like a projection. Then you have like joins, semantic joins, which is just like, think of it like as the regular join. The difference is that a regular join requires like exact matches between like the columns. Now, instead of exact matches, you have not just like fuzzy matching, but you match actually in meaning, right? So you can go and match, like do like a join, but instead of expecting that the values are like exact, the matching is going to happen like through like based on like the meaning that the two columns have. So it should feel like familiar to them, like to use it. It is obviously like a little bit different in the sense that you have to think of, oh, I am joining on meaning, not on syntax, right? But that makes you focus more on the data and understanding, let's say, like what it means for your data than how to implement that, right? Which is what we are trying like to remove from the equation for like people out there. The other thing is that everything like we did, we added like some, like one of the interesting things I think like is you see the impact that new technologies have by observing the data types, in my opinion, that data systems support, right? So in 2010, we didn't have that many, probably we didn't have any OLAP system at all that was supporting something like JSON, right? Today we take it for granted that you have structs and you have like more unstructured, like variant types, for example, right? That we can use. That wasn't like true with even like Redshift, for example. It was like a big problem of like, okay, we get all this data from like the APIs that now we can pull data out, but these are like JSON and we cannot query these like efficiently. We have to do a lot of ugly wrangling of the data like to make it work. So there are like new data types, in my opinion, that we also need now that we are working like with LLMs. And one of the things that someone can see like investigating like Fenic is that we are experimenting with that too. So we have a new data type that's called Markdown. Markdown has it's kind of funny because like Markdown was never like intended to be something to define structure, right? It was like intended to define styling, but we ended up like using it like as humans like to define structure too. And LLMs rely a lot on that structure, right? So we introduced like new data types like Markdown that you can use in a similar way that you could use like JSON, and you can turn them into like proper structs and then go and do like the analysis there as you would do like with JSON. So in my opinion, like the best way for someone to work with Fenic is use the MCP, the documentation MCP server we have, which by the way is built using Fenic itself. So Fenic is used like we have like a pipeline that goes through the code base itself whenever we have a new release and creates like a data set using the semantic operators that we have together with the normal operators to create artifacts and tools that an LLM can use like to understand how to use Fenic correctly. Connect like something like Cloud Code and just ask it to build something using Fenic, or even ask for a tutorial. So that's the I would say like the easiest way to get familiar with Fenic and use it, and hopefully it's a little bit of a glimpse in the future of like how I believe that like we will be writing code, and hopefully will change also how hard it is for people like in the industry to adopt new paradigms like and APIs and architectures.
And so now digging more into the ecosystem integration, you already mentioned the built-in compatibility with Polars and DuckDB. And I'm wondering if you can just talk to some of the ways that you see Fenic fitting into a typical data transformation pipeline, and in particular, as people are using a lot of those pipelines to feed context into AI and agentic systems, the role that Fenic plays in that context engineering workflow.
Yeah, 100%. So the way that we are also like using Fenic, and I think like the best way like to use it is it's more of like a system that's supposed to be used like locally, right? Like it's not like a substitute of like a full blown like Spark cluster. That's not what like Fenic is for. It's like something that you can run like in one instance that you have. Now, what Fenic does is it has like some primitives that it makes it ideal to mess with your context without having your main agent having like to spend tokens and context on that. So if we think about like context engineering, let's say, at the end of the day, it's primarily state management, but state management in like a very specific constraints, right? Like you have like the constraints, like you have like short-term context management that you have to do, long-term context management that you have to do, and you also have like to work with tools, which is like a new API, and also you have to work with semantics a lot, right? So it's not just like a key value store on its alone, like it wouldn't be enough in order like to manipulate like the context. And that's where I think like Fenic really shines here. It has like the expressivity, both in terms of like applying any traditional like standard classical, whatever we want to call it, like data processing, right? By using like data frames in a declarative way. So focusing on what your context should look like, not how to create it. Use inference and offload inference from the main agent to Fenic to go and create the artifacts that you need like for your context, and retrieve it also through like the toolings that like Fenic provides for that. So the way that I think like people like should think about it is like a library that you can add in any agentic framework that you have to build memory modules or context management modules, either short term or like longer term, because you can persist the data too. And most importantly, offload inference from the main agentic loop to Fenic to do part of like the context management. So if you want to summarize as part of your compaction, like don't do that like in your main agentic loop. Offload it like to Fenic and the semantic operators like to go and do it. And store it in a way that you have like full lineage of that, so you can roll back if you want, right? Like you pretty much have like complete all-up system that can fit as a companion like to your agent, and use that to manage and serve the context for your agent. So it doesn't replace the agentic frameworks, right? It's not harness like to run agents. It is like it should be thought as something that can enhance your like agentic framework that you use, like Pydantic AI or like LangGraph or anything else, and build the state management, the context management using Fenic.
And then the other interesting aspect of integrating with the broader ecosystem, particularly as we talk about agentic use cases, is the role that it plays in conjunction with some of these agent frameworks such as LangChain, Pydantic AI, and the list is far longer than I am aware of at this point.
Yeah, 100%. I think there is a difference. I mean, the agentic framework is and it should be all about, let's say, like the agentic loop, right? Like what give the primitives to define like, let's say, the broader like behavior of like your agent, keeping in mind that the agent and LLMs in general, right, it's like a stateless thing. It's like you put tokens in there, like you can't offload the state management to the agent itself. Like it's not going like to work. So if you make this clear in your mind as an engineer that, okay, my agent is, let's say, like the logic that runs there and it's stateless, like anyone who's coming like from functional programming, like I think it would feel like pretty natural, right? Like it's a function, gets like some tokens in and spits out like some tokens and that's it. No side effects, nothing, right? Like there's nothing else there. So the question then is like, okay, because this context affects heavily like the behavior and the quality and the performance of this thing, like now how we are going like to manage that. And I do think that it should be separated like from the framework itself and portable also. Like it should be something that you can even like use it between like different agentic like frameworks, right? And that's kind of like another value that you get with something like Fenic. Like you can build these like with Pydantic AI. At the end of the day, like your context is going like to be stored into either like some Parquet files or like a DuckDB file. You can use the same library also like in another like agentic framework and still access like the same content, right? And if you use MCP also among like frameworks that are not only like in Python, it can be like in any framework you want.
And as you have been building Fenic and working with the community and with some of your customers at TypeDef, what are some of the most interesting or innovative or unexpected ways that you're seeing it used?
I would say like most interesting, I'll say two. One is like kind of like an internal one, is like the documentation use case where you go directly from the code base to actionable documentation for an agent without having to write the documentation itself. That's one. The other one is using it. We had like some use cases where it has been used to do some very interesting analytic pipelines that I just can't say like, because sometimes it will come out like from like the people who used it, and I don't want like to share that before they do it themselves because it's their content. But they took like content like from many years of like posting on like newsletters and some other platforms, and they managed like to use it to create like analytics at the end that they are very rich on extremely unstructured data. So we are talking about like pretty much, let's say, like blog posts and like audio files, and somehow like get all that and like create literally a star schema at the end that you can put like a semantic layer on top of it and use even like an agentic analytics framework to go and get really quantifiable like results, and all that coming from like completely like unstructured information. That was like pretty fascinating like to see, and most importantly how you needed both LLMs and also standard OLAP operations in order like to make it work at the end.
And in your work of building this framework and building a business with that as one of the core technologies, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process of bringing these semantic operators into this data frame primitive?
I would say like two things. One, like a positive, and one that is a bit of a challenge. The positive one is that by having access like to LLMs, you can accelerate a lot the development of like features that in the past wouldn't be like possible to be done by a startup. And especially like in the data infrastructure world, like I'll give like an example. Let's say you're trying to support SQL. SQL has many different dialects. Many different dialects is not like only like a syntactical issue, it's also like a semantic issue, right? That you have there. Like the semantics are like slightly different also. Now, supporting all the different dialects out there, it's like an impossible feat. Like it's super hard like to do. LLMs allow you like to accelerate this a lot. Like you can get code, let's say from, I don't know, like let's say like Teradata, right? And I'm using Teradata just because it's something that it's not necessarily accessible easily, like to go and find like code out there and work on it and create like part or get open source like tooling for that. And still like you can use LLMs if you are careful, because you have to do a lot of processing that deterministically like it would take like a lot of very hard work and a lot of time like to make it happen. Now you still want like to get to the deterministic version of like the code, but it allows you to go and provide and prove the value really fast, and then gradually start adding more and more determinism like as you go. That's one of the like the big benefits I see there, and I hope that we will see a lot of like the problems in the data world like actually being solved because of having access like to these systems, and allowing like data engineers and engineers in general like to align on the different semantics of all these systems like much faster and more reliably than they could before. On the other hand, you have to change the way that you build. Building software and systems is almost like a shocking experience when you have like to do it with LLMs in the mix. Me, because I've been exposed a lot like to the product management world also, kind of like reminds me of how you do product development with A/B testing. You don't you need to build all these like evals and like benchmark frameworks, and you do that not because like you're just trying to improve a metric, is because you are trying to understand the behavior of the model with the tools that you have against the problem that you have, and adapt the software around it in a way that the agent will be better in what it's doing, which is kind of like what product development with A/B testing is, right? Like, should we expose to humans this way of like doing this workflow or another way? There's not necessarily like a proof, right, that will take you through like to figure it out. You have to test it, and it's hard, especially like for systems engineers that like they think in terms of invariants and like proofs and like all that stuff to change the way you build software. But it's fascinating. Like I don't know, I find it like really fascinating.
And so, for people who want to take advantage of some of these LLM capabilities in their data workflows, what are the situations where Fenic is the wrong choice?
Don't use Fenic to build a chat with an LLM. You can do it, but it will be painful and not efficient. That's not the goal. The goal of like using Fenic is to process data using LLMs and do it in a structured way, in a reliable way, and like at some scale, right? If you just want to process one PDF, throw PDF like on ChatGPT. just copy paste it there. Like you don't need to load it into the data frame and like go like and process it. Now, are you continuously going like to working with PDFs as they come in, and you want to be able like to identify where issues in your pipeline come up when they come up? Then yeah, use a structured way like to approach data processing and use something like Fenic to do.
And you mentioned earlier that Fenic is largely focused on single machine compute. I'm wondering what you see as some of the opportunity for integrating with some of the engines such as Ray or Spark or Dask for being able to do scale out capabilities across multiple machines.
Yeah, I think there's definitely like opportunity there. I think like the same way that someone would use, let's say, LangChain, people like primarily using it like through creating UDFs. I think with something like Fenic, and that's something that we should invest like some time on it, like to make it more performant and more like easy like to integrate with that systems. I think it's a much more natural fit to integrate with like either Ray or like Spark and run these jobs there.
And as you continue to build and iterate on Fennec, what are some of the things you have planned for the near to medium term, or maybe some of the ways that you're thinking about the decision points where it makes sense to bring in additional semantic operators to the core?
Yeah, so far, I mean, I think the way that the API is defined right now, you have like different layers of expressivity with the semantic layers, with semantic operators, sorry. So at the end, you can just do a map, a semantic map, which is almost like a direct call like to LLM, like to generate some output. And you can either have an output schema defined or not. So it's quite open at the end. I think like if we need like to introduce new operators, that should come from seeing when people reach out like to use map and what are like some patterns there that they can be abstracted. Outside of that, I would say that right now, and I feel like from the literature also, like from what's been like published out there, I think the coverage of what you can do with the semantic operators is like pretty good. I think it's more about focusing on the performance and optimization side of things. How we can add new passes on the optimizer specifically for like LLMs to make the whole thing like much more efficient, and add even more like say like fault tolerance in the mix, because that's like I would say like at scale at least, like when you're working like with bots, the biggest like I say like problems like to solve, and the most interesting also from a systems engineering perspective like problems. There are some very interesting things that can be done there, like for example, depending on like when the inference happens, how you can sort your columns in a way that caching is much more efficient on the inference engine side. What I'd love to see as an engineer is to actually bridge the optimizer with the inference engine too. So make the optimizer aware of the inference engine and using that information to optimize like the plans in a way that will optimize the batch inference that happens there too, not just like on the CPU side.
Are there any other aspects of the work that you're doing on Fennec, the use cases that it supports, or the overall engineering effort involved that we didn't discuss yet that you'd like to cover before we close out the show?
No, for me, I would like to think of like Fenic as an experiment in a very interesting point in time. I'd love to hear from people like how they think and like in what new ways they can either like make it work or break it, and help all of us like the open source community, and that's obviously like at TypeDev like to learn and shape this new world of like inference and traditional like data processing, and like how these will fuse like together. I think it's like a great opportunity, and hopefully there's a lot like to be brought into this space like from all the practitioners like in the data world, like special like data engineers as I said. And I hope that Fenic can be like a platform like to do that.
All right. Well, for anybody who wants to follow along with you and get in touch, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap of the tooling or technology that's available for data management today.
I think that that's a big conversation. Maybe we can probably have like a full episode like talking about that. I think if we want like to be accurate here, we have like to make like a distinction between like the enterprise world and like the rest of the world. The reason I'm saying that is because the problems manifest like a little bit like differently between the two. The main problem in my opinion is like fragmentation in terms of like the tooling. Just that, let's say like the enterprise uh, experiences that not just like as like fragmentation, but also fragmentation with a lot of like legacy systems too. So there is a question there, like systems that they've been around for like 25 years, like literally, like you talk with people like in this big enterprise and they say people retire and we lose institutional knowledge about like these systems, and you cannot just like rip them off. And like, people like joke about COBOL, for example, like in the programming language space, but like in the data space the problem is even harder. But this fragmentation, like if you go in, let's say like companies that they are more like digital native, or they grew inside like the, let's say the modern data stack, whatever we want like to call it, exists there too. There is like a lot of like fragmentation, and this fragmentation is like it does create problems. So the question is how we can bridge these tools like together, and how we can make like the data practitioners actually like increase their bandwidth instead of like actually droning into like more work. Because now we don't only have like humans doing BI, we will have 1,000 agents also like making queries that make no sense. And these people will be responsible for like maintaining the infrastructure in a way that can keep like driving business decisions, right? Maybe LLMs can help. I don't know. It's something that it's definitely like problem and a big opportunity in my opinion in the space.
Absolutely. Well, thank you very much for taking the time today to join me and share the work that you're doing on Fenic and introducing these semantic primitives into the data frame abstraction. It's definitely a very interesting project. It's great to see the work that you've put into that and the ability to meld these two different worlds and functionalities into a single interface. So I appreciate all of the time that you've put into that, and I hope you enjoy the rest of your day.
Thank you so much, and thank you to your audience for like listening and hopefully giving an opportunity to Fenic and give some feedback to us.
You're a developer who wants to innovate. Instead, you're stuck fixing bottlenecks and fighting legacy code. MongoDB can help. It's a flexible, unified platform that's built for developers by developers. MongoDB is asset compliant, enterprise ready, with the capabilities you need to ship AI apps fast. That's why so many of the Fortune 500 trust MongoDB with their most critical workloads. Ready to think outside rows and columns? Start building at mongodb.com/build today.